Good morning, everyone. Welcome back. Previous week, we start with C++. Hopefully, you have the opportunity to copy-paste some of the source code that we review and compile and run C++ source code in your systems. Maybe check your compiler and get familiar with the new library and the new instructions saying so. Anyway, if you haven't done that, please go ahead, start your practice. You're going to have grades for the midterm this week. Very soon, we're finishing with some things, but you're going to have your grade for your midterm. Now you can start preparing your final. I post an announcement with the date of the final exam, basically the last day, the first day of December, our last week of classes. Take a look if you haven't reviewed that. Now, moving forward with C++. We need to talk about memory management. We need to talk about the equivalent of malloc and free. Before that, just to be sure that you remember C++, classes are back. We can create classes and we have two options. We can create everything in one file. So in the same file, in the same class, we can put the body of the class and the body of the method, just like you are used to do in Java. Everything in one place, and it could be one file. Important thing to remember, the main is not inside of any class. This example, I have one class, the class have its own methods inside. You know that the class finished because the curly bracket and the semicolon. Outside, my main method, line 20, line 21. These two are connected. I am giving you two columns used to use the full screen. Now, important, private, protected, and public. Here, you do not put the words before the variables or before the methods. They are kind of headers for three different paragraphs, but they work in a similar way that they used to work with Java, public, private, protected. The name for our library now is not stdio.h, now is iostream, and without the h, that is a signature for the C++ classes. Moreover, this library gives us access to cout and also to the equivalent cin to put something in the screen or read from the keyboard. You're going to use that in your assignment. Next, we have constructors, just like in Java, and we can use classes to create objects. We can create objects on the heap or the stack. This in particular, creating an object without the new thing, like in Java, or without the malloc thing in C, that one is an object, is complete. That works, but that one is in the stack. You can create an object in the heap. You can use the new. We're going to talk more about new today. But if you use new, your object go to the heap, and this guy is a pointer. In C++, you have objects or pointers to objects. Objects in the stack, pointer to objects, then the object is in the heap as usual. If you're using pointers, it's because you're pointing to something out of your stack. Now, in order to call methods or variables that are public in your objects, the dot, as usual. But if you have a pointer to an object, just like this, in which you use the new, you can use the dot and the asterisk. Remember structs in C? Or we can use the arrow. Obviously, very, very common, and we're going to follow that standard using the arrow. The arrow is going to be the one that we use with objects, pointers to objects in order to access variables and methods. Option number one. Option number two, you can have a class and you can create two separate files. You can have a class and you can have for your class a .h file and a .cpp file. This is very useful when you're creating libraries. This is very useful when you want to share your classes with someone else. This is very useful when someone else is going to use your class and that someone else do not care about the details of the implementation, but just about the services that your class offer. So you can create a .h class, the .h like this one, the class name, open, close the class, inside, public, private, protected, variables, and your methods, but your methods without body. Use the signature. We call signature to the type, the name, the parameters. Moreover, for the parameters, you can put the names here, that is totally fine, or you can delete the names. The only thing that the computer cares is the type for the parameters and the number. Remember, the names are irrelevant. So you can put this in a .h, and then in a separate file, you can put the bodies for the methods. The only thing that you have here is the body of the methods that we declare here inside of the class. Now, the connection between these two files is this include here. You include the .h in the .cpp. And remember, quotation marks for the include. We do not use the angular brackets because this time is not part of the library, is my file. I want the compiler to find this file in my own project. So quotation marks. Now, quotation marks, in order to tell the computer that this time or this set print are the body of methods that you create inside of a class, well, we need to put the name of the class before the name of the method. Moreover, we need to connect the name of the class with the name of the method with a new operator. We cannot use the dot, because if we use the dot, this will be something like we are calling the method, right? Like time.time or time.setTime will look like we are calling the method using the name of the class, therefore something like the methods are static, whatever. We just want to connect this method with the .h. What we use for this, and we're going to use this a lot, is this operator here. It's an operator, even though it's two symbols, colon, colon. And that one have a name. Remember the name of that new operator. Scope resolution operator, right? Scope resolution operator. That is going to be your friend in several different things. Now, name of the class, scope resolution operator, and then this is basically the same thing that you have in the .h, and here you can add the body, whatever the body is. In the CPP, you can put the main there, or you can create another CPP for the main, up to you, depending on how you want to organize your source code. But notice that if you put the main do not need the scope resolution operator, the main do not need the name of the class, the main do not belong to the class. It's an independent method. Here, the last thing important to remember is we have attributes, variables that are global inside of a class, but also we have global variables, real global variables. If I create here a variable W, that one, the variable W, is a real global variable. That variable can be used in any method in this program and is not an attribute inside of my class. This W is different than this hour or minute. Hour and minute are global, quotation mark, because they can be used in any of these methods. Here, 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 or here. But that hour and minute cannot be used here. The only way to use hour and minute here is if they are public or if I call a method. They are global inside of the class. They are attributes. The methods of the class can use it, but other methods outside of the class, including the main, cannot. This variable here, W, do not belong to any class. That one is a real global variable. That one can be used in any method outside of any class. Good. So big summary of the previous lecture. Now, moving forward, memory management. Memory management, 3 things that we need to review. 3 things. Number 1, you remember our friend, the keyword static. Static exists in C++. There is a static keyword. And the goal of the static keyword is exactly the same as the static in Java. Well, at least the static for the variables. What is the goal of the static keyword in Java when used with variables? What happens when you have a class and inside of the class you create a static variable int? Why do we want to do that variable inside of the class static? I am talking about Java. Can you agree with me that every single time in this example that you create a new object from my class, whatever, inside of the class, you have a variable y? That is just the theoretical background with objects, right? Each object have all the variables that you put in the class. But when you have one variable and that one variable is static, what you are representing is that variable can be used by all the objects, but is one and only one. All the objects share that variable, right? It's only one copy of the variable. So if you put a value in the y here and a different value here, that is fine. But if you put a value here, this object, and then this object change that value, the value is changing for both of the objects. That is the first time that you do something like this with programming, when you start using static variables, when you start using this variable that, well, it's only one, but it's inside of the class. Yeah, all the objects have access, but all of them share the same space. When some of them do something, it's going to be the same one. You review that with Java, that is going to exist also with C. We're going to review one example, static variables. Now, next, you know constructors. We need to review the structures. Constructor, destructor. We mentioned this before. The first method that we run when we create an object. Now we need to talk about the last method that is going to run. And new and delete. I mentioned before, new is our new malloc, and delete is going to be our equivalent to free. Malloc and free for C, new and delete C++. We need to review examples of those 3 things for today. Good. Now, starting with the static. Static in C++. I need a static variable, very, very easy. The same thing that you do in Java. Static is a keyword. You put the keyword before the type of the variable. Done. You have a static variable. Wait, only one thing. In Java, when you have a static variable and you want to put an initial value to that variable, usually in Java, you will do something like, well, static in my variable, and I want that variable to have an initial value. You put your initial value there, right? Java. Moreover, if the initial value in Java is want to be 0, you do not need to initialize. By default, all your variables, primitive variables in Java are 0 because your virtual machine takes care of that. Bad news. Number 1, in C++, you cannot put values to the variables here. That is going to give you a problem. You cannot put values to the variables, the static ones, there. The only thing that you can do in the line 7 is to create the static variable, static int, and whatever name you want. You cannot give a value there. Why? Well, because every single time that you create an object, you are reading this line 7. And you want to put a value in the variable only one time because there is only one variable. C++ is not going to allow you to do that, but Java allows me to do that. Java. A lot of things are not exactly good with Java. This thing cannot be done. So obviously the question is, okay, if I cannot put an initial value there, then where? Outside of the class. In order to put an initial value to a static variable, I need to do that outside of the class? Yes, outside of the class. So starting in the line 11, you can put a value to your variable. But my variable is counter A. And if the only place in which I can put a value to that variable, like equals 0, is outside of the class, how my compiler is going to know that that one is the variable that belongs to the class and not a new one with the same name? You are going to use the scope resolution operator, and before the scope resolution operator, you're going to put the name of the class. Moreover, and this is tricky, mandatory, you need to put the type of the variable again. But that looks like I am creating a declaration for the second time. Yes, that is the way that it works. The only thing that you do not do is to put the static again. So if I want a static variable, number one, declare the variable inside of the class and use the static keyword. Number two, outside of the class, put the data type again, scope resolution operator with the name of the class, the name of the variable, and now finally you can put equal to whatever you want. And that is going to be the initial value for your variable. This is the only tricky part for static variables in C++. Be careful. Something like this, that one, counter, is a global variable. Nothing to do with the class. That one is a variable. Counter is not part of any class. You notice there is no name of the class. There is no scope resolution operator. It's just a global variable in the program. But this one here is a variable. It's a variable from this class. And I know that this is static just because only the static variables need a value outside of the class. I do not need the static keyword. I need the data type here and here. That's it. Okay, let's see. I have counter A that is static and with the initial value 0. I have counter B that is a local variable in the class, a global variable in the class, an attribute, but it's not static. And I have this counter that is global. 3 different counters in 3 different scopes. What is going to happen with them? Let's review an example. Before of that, which is the initial value of any of these variables if I do not put the equals 0? C++, initial value. If they are pointers, null, but they are not pointers, which is the initial value for these integer variables? Okay, in Java, 0, yes. In C, garbage. In C++, garbage. If you do not put an initial value to your variables, the initial value is whatever was in the memory in the place in which the variable is being created. Remember, the only reason because in Java your variables have an initial value 0 is because you have this very fancy virtual machine taking care of you, giving you spaces that are clean. C and C++, they do not have virtual machine. what you have inside of a variable when you declare the variable is garbage. That is the reason because in C++, you are going to notice a lot of initialization equal 0. That is something that you never have in Java, right? You need to put the 0 if you want the 0 there. Counter, counter A, counter B. Counter and counter A equal to 0. Counter B right now have garbage. Moving forward, a simple example. I have this, the body of the methods in my previous class, right? I create a class. I didn't put here the bodies, so I am adding the bodies outside. This is a CPP, the other can be a .h. Inside of the main here, I am creating three objects in the heap or in the stack. F1, F2, F3, they are objects from the class foo. They live in the heap or in the stack. Yes, in the stack. Because the only way for them to be in the heap is using pointers. I am not using pointers yet. So they are in the stack. Three objects from my class foo. My class foo have this counter B private. So these have a counter B variable. These have a counter B variable. And this one have a counter B variable. They are private, they are in the objects, they are there. Also, I have this counter A. Counter A is static and therefore is something that this object can use, this object can use, this object can use. I am using arrows like lines to connect the object with the static variable, but I am not talking about pointers. Use a line to let you know that the three objects have access to that variable because that variable, counter A, is part of the class. However, the variable itself is outside of the objects because there is only one variable, static. The three objects or all the objects from the class is going to share that space. If I call the method counting from F1, F2, F2 again, and F3, counting is increasing the values of the variables. Counter A and counter B. Here, F1.counting. F1, F2, F3. F1 counting is going to increase in one the value for the variable A and in one the value for the variable B. F1 is going to put a 1 here and also a 1 here. Remember, all of them are 0, right? Done. Now is the time for F2. F2 is going to increase the 0 here to a 1, but also is going to increase the value of CA. Hopefully you agree with me. It's going to increase the 1. It's going to be, this is 2. And it's 2 for all of them, even though F2 is the one that makes the change. I am going to call F2 counting again, which is going to do an increment of this one here, 2, but also is going to do an increment of this one here to 3. And then I am going to call F3 counting, and it's going to make a 1 here, 0 plus 1. And also is going to do an A increment. That one is going to be comma 4. 1, 2, 3, 4 calls to the method, 4 increments to A, the only A. 1, 1, 2 inside of the objects. Private variables, the static one. The static one, all the objects are sharing the variable, used like in Java. So all of them can increase that shared value. And they can increase or modify its own variables. So far, so good. If I want to print things, I can use cout. If I want to print the private variables in my objects, I can call a getter. So I can print B in F1, or I can print B in F2. So with the getters, I can print this 1 on the screen, or I can print this 2 on the screen, or even I could print this other one for F3 in the screen. Getters. For the static one, if I have that one public, that is usually the case, I can just do name of the class, scope resolution operator, name of the variable. And with this, I can print the 4, that is the variable, the value there. If you remember in Java, in order to access static variables, you use the name of the class, just like here. But instead of the scope resolution operator, you use the dot, name of the class, dot, name of the variable, static and public. Here, we are going to use with the static variables, the scope resolution operator, even for printing or storing a value there. This is the new way. Makes sense? Static variables, initialization, declaration, and how to use that outside of the class. Easy, right? The only new thing, using the scope resolution operator. That is the only thing that changed, and the initialization outside of the class. Other than that, everything just like in Java. Good. Moving forward, something more complex. Destructors. Because constructors, you already know them. So, yes, you can have it. It's very common, not only with Java, but also with C, have these public variables when they are static. So not only the objects, but other methods can have access. So public, but in a similar way that you did before with Java, you can have getters for those variables. It is possible. Destructors. You already know constructors. Easy. You use constructors at least one full semester. Destructor. Oh, this is when the object is born. This is when the object dies. The reason because now we have destructors is because now we do not have the garbage collector. Destructors are the replacement for the garbage collector. The destructor is your last chance to clean the space that you use. The destructor body is the last opportunity that you have as a programmer to clean your space. And usually cleaning means clean the memory. But it could also be related with stop a process. So you do not want to finish your program and you still have threads running or something like that that are going to continue running without a program that is responsible for those threads. But most of the time, and the topic that I want to cover here is destructors for cleaning the memory. Destructors as the place for the delete, the freeze. Let's check. Example. If I show you this example, and I am going to use this .h file, .cpp file, just to keep things separate. If I ask you about the methods here, it's very easy to identify that you have these methods. You know the method because they have a name and you identify the parentheses. Yeah, you can have static, private, public, protected, just like in Java. All of that works. My example in particular, and in order to access the variable without the setter getter is public. If you move that to private, the only thing that you need to consider is methods public methods like the setters and the getters that give you access to the variable. That's it. Going back to this method, you identify the method clearly, those with the parentheses. Now, moreover, you identify your constructor. You identify the constructor because it's the one that have the same name of the class. Destructors. Destructors also have the same name of the class with one extra character. That character and the name of the class, and that is the destructor of the class. Every single time that you check a class and your class have the name of the class and before the first character, extra character, together with the name of the class is this one, that is a destructor. You are creating a destructor for your class. Moreover, destructors do not have parameters, never. The destructor do not receive parameters. And because the destructor do not have parameters and do not have a data type either, no data type for the constructor, no data type for the destructor, the constructor can have different versions because you can have constructor with and without parameters. For the destructor, never parameters. So destructors cannot be overloaded. You have one and only one destructor per class. That's it. Okay, so one constructor, one constructor here, the default one, another constructor here with one parameter, and only one destructor. Can you add more constructors? Yes, constructors, as many as you want. Can you add more destructors? Never, only one, always, without parameters. Good. I want to put a body to them, just like with any other method. Name of the method, name of the class, scope resolution operator. Name of the method, name of the class, scope resolution operator. You are noticing there is no type before because the constructors do not have a type. Destructor, same. Our new character as a prefix, the name of the class, that one is a destructor. Moreover, you said before, usually you're going to have inside of the parentheses, the keyword void when you do not have parameters. You're going to read that in the textbooks. Is pretty common. If you feel uncomfortable with that, like a void inside of the parentheses, you want to delete that and have something like this, go ahead. This one and this one, empty parentheses is fine. Or you want to put void in both, go ahead, put void in both. The only reason because I add the void there is if you go and read the book, if you go and watch some kind of source coding on the internet, you do not get surprised. Void or empty parentheses, fine. Okay, so name of the method, name of the class, scope resolution operator, the body for my three methods, two constructors, one destructor. Inside of the method, the only thing that I am doing right now, let's print something. Just to play with them, print something. Print destructor or print constructor, whatever, constructor, whatever. It's just a message. And then I have my main. How many objects I am creating in the main? Can you agree with me? 2 objects. How many times this message, constructor void, is going to be printed on the screen? How many times this constructor int message is going to be printed on the screen? How many times this constructor or this constructor is going to be called? Hopefully you agree with me here. When you are creating this object Q1 and you are sending this parameter here, what you are going to print there is this message. because this line is calling that constructor. You already know that. In this line, when you are creating an object and you are not using parentheses, you are not passing parameters, hopefully you agree with me that this one is calling that constructor. So you have those two messages on the screen. They are going to be executed. You're going to have them on the screen. The question here is, how many times in this main, used with this code, the destructor message is going to be printed? I do not have deletes. I am not calling the method, any method there with the apostrophe. It's going to print the structure in any point. That is the output of the program. Who is calling the destructor? In which point? 2 times the destructor was called. Well, just as happened with the constructors, the destructors are called automatically. Automatically, you do not need to do anything to call destructors. Where they are going to be called? Exactly in this point. When you close the main, your program finish. When your program finish, your objects are going to die. They are going to be removed from the memory. The last thing that is going to happen here is each of these two is going to call the destructor method automatically. So you do not have a garbage collector, but now every single time that any of your objects is almost to be removed from the memory, the destructor is going to be called, and you're going to notice that there. 2 times the constructor, 2 times the destructor. Always, always, always. If you create something, you call the constructor. When that something dies, you call the destructor, always. There is no way that the destructor is not executed. Now, here, guys, very, very important. If you are running this program, this one, copy paste your program, and if you run this program in any fancy IDE, anyone, those fancy IDEs that run the program and open a window to show you the results, and when the program finishes, they close the window. If you have one of those, Visual Studio, you are not going to be able to show these messages. Professor, my program is not working with the destructors because run the program, I read the constructor's lines, and then my program finished. My program never print anything for the destructors. My program is not calling the destructors. Your program is calling the destructors. Your IDE is closing the window and you are not able to show the result. It's something with your IDE, not something with the destructors or your program. So if you have one of those fancy IDEs that close the window when the program finishes, fix it. If you have any other, those that have the console below, those that show you the result and keep the result there, this is the result that you get. The destructors are called after the program finish. Exactly in this point. There are going to be a lot of questions in your exam and in your quizzes like this. A lot. Please copy paste this source code and be sure that you agree that this is the result. If you have any problem, if you do not see this result or you are not able to get this result, contact me or the TA. We can help you with your IDE. But this is the behavior of the destructors. Good? Okay, this was easy. Let's do something more complicated, because constructors and destructors with objects that are in the stack are very simple. what happened when we mix not only the stack, but now memory management? What happened if we start using delete? If I want to use delete, I need to use new. So new and delete. And I am going to mix this with constructors and destructors. Let's see, new and delete. Another example, I am going to use the same class that I had before. The only thing that I am going to do is change the main. So this is the same Q class that we had before, same constructor, same destructor, and same messages. There, I am calling a constructor, right? I am calling the constructor that have one parameter. There, I create an object. That object is in the stack. That object is going to live in some place there, my stack. Then I can create a pointer here. Question, here in this line number 2, I am calling a constructor, yes or no? Question in your exam. Q asterisk my Q is calling a constructor, yes or no? No. Great, thank you. Here you call a constructor, you are creating an object. Here you're creating a pointer, and when you're creating a pointer, what you are creating here is a variable that is going to have inside a number. You are not creating an object, therefore this line do not call a constructor. That line is not going to print anything, not yet. Clear, right? Constructor, when you create an object, you are creating an object here. Here, you're creating a pointer, not an object, it's a pointer to an object. No constructor, not yet. New, name of the class, parameter. Here, are we calling a constructor? And hopefully you agree with me, is yes. Here we are calling a constructor. In fact, that is the place in which you call a constructor in Java. Remember when you have the new? In the 2 arrows in which I put a dot, a circle, those are the 2 points in which you call the constructor. In fact, you are calling the same constructor, the constructor that receives a parameter, a number. To create an object in the stack, this one, to create an object in the heap. This pointer is going to be pointing to the heap, and there is going to be an object here, and the address is going to be here. This one is my Q2, and this one is my Q. The one in the stack, my Q2, the one in the heap, my Q, the pointer. Good. 2 calls to constructors, 2 times the same constructor, the same with parameter. And then I can use the objects. With the one with the pointer, I can call the method using the arrow. The one that is an object, I can call the method using the dot. We already talked about that. And then, important thing, delete. Every single time that you use new, you need to do the delete. It's your responsibility to clean the heap. You are the one that put this object here. You are the one that need to remove that object from there. So you do a delete, and you do that with the name of the pointer. The name of the pointer is my Q. So delete my Q. That instruction is going to clean this space, just like you're free in C. Exactly in this point, the delete instruction is going to do something before cleaning the space. The last thing, or something that the delete instruction is going to do before cleaning, is to call the destructor. delete call the destructor. The closing curly bracket of the main call the destructor. In this point, you are going to notice that the destructor of this object is called. In that point, you can stop your program and you have a message on the screen, destructor, because the destructor was executed. And right now, the only thing that I am doing there is to print a message, just for you to know that that method was executed. You can put whatever you need inside of the method. Delete for my queue. Question in your exam. Do you need to do, or it could be correct to do a delete for my Q2, a delete for this object? True or false, correct or incorrect? Question in your exam, and my expectation is that you answer, you cannot use delete for my Q2. Why? Because you do not use new. You need delete if you use new. They are together, remember? Parentheses, new, delete. You use new for this one, my Q. You need delete for my Q. My Q2, you never use new. You do not use delete. It's a problem. It's an error. Why to use delete if you didn't do the new? You do not use delete for something that is in the stack. When this object in the stack is going to die? Everything that you put in the stack is cleaned, is deleted when the method finish. This one, the destructor for this one is going to be called here. Anything that you put in the stack is going to die when the method die, in this case, the main. Everything that you create with the new is going to die only if you run delete. If you do not do the delete, this object is not going to die, and therefore the destructor is not going to be executed. If you run this program just like the previous one, your output should be 2 calls for the constructor and 2 calls for the destructor. 2 objects, both of them call the same constructor, the one with the integer parameter. The 2 of them call the destructor. First, the pointer here, and then the other object when the method finish. Clear? Constructors and destructors. Good. So, next one. I have a class Q, still similar to the previous one. I have my methods, and something that is very, very common to do is every single time that you have a class and your class have inside any kind of pointer. Remember, arrays are pointers, strings are pointers, and several data structures. What you have is really a pointer to the head in a linked list, a pointer to the root in a tree, pointers. So every single time that you have a pointer in a class, array, string, or data structure, the recommendation, the pattern for programming is the following. For this pointer, inside of your constructors, you can put your news, or you can initialize with a null value, whatever. The constructors are for giving value to your pointers. Any pointer in your class should receive a value in the constructors of the class, either null, because it's going to be empty, or new something. This one is an array, new, integers, and the size. Did you notice that this looks like Java? Anyway, now the destructor, something that we usually do is in the destructor, you put the deletes to clean your pointers. So every time that you have an object, your object have pointers, the constructor of your object create the data for the pointers, the destructor of your object clean the space. So each object create things, clean things. Theoretically, because the destructor is always executed, always, you are going to run the deletes for those things that you create. And always, those things are going to be created because you are giving a new in your constructor, and the constructor is creating your object. Well, it's going to create your object, and also it's going to create those things like this array that the objects need. One small parenthesis here. If you create with new an array, if you use new and you use the square brackets, when you do a delete, you use also the square brackets. You delete also an array. There is delete and there is delete square brackets. Just like that, empty together is delete, or two options. A name. In the first scenario is a pointer. In the second scenario is a pointer to an array of whatever. How do you know if you create an array of no? If you use the new and you use the square brackets, you create an array. Therefore, you need to delete as an array. If you didn't use these ones here, you do not need these ones here. Delete, new. For arrays, for objects, for arrays, with the square bracket, both in the new and in the delete. Okay, so according with this, news and delete for the buffer, news and delete for my array of integers, whatever, I don't care. The new. How many objects do I have in this main here? Total. How many times the constructor is going to be executed? Total. 3. Can you agree with me? 2 times the constructor with parameter, 1 time the constructor without parameter. I have only a delete, 1 delete. How many times the destructor is going to be executed? Only 1, because the delete, or more. 3. Again, 3 constructors, 3 destructors. That's it. What happened with this array? That array is an array of integers. The integers do not have constructor or destructors. So this new here and this delete here, arrays. The constructor and the destructors are for the objects. And I have 3 objects, 3 constructors, 3 destructors. Objects, constructor, destructors. New and delete with primitive data. That primitive data do not have these methods. Good. So everything in the stack is going to be deleted, is going to disappear, or is going to call a destructor at the end of the method. Anything in the heap should be deleted explicitly with the delete instruction. And in that point, it's going to call the method destructor. Those are the rules. Very, very simple. Just to close this, this program. If I show you this program and I show you the output here, can you agree that that one is the output? Can you explain me why that is the output? And now that you finish with your midterm, I am sure that you are expecting this program to be in your final, And yes, you're right. Something like this can be in your final. So let's check what we have here. Why that is the output of this program. At this point, all the lines here, all the instructions here should be clear. It's a combination of what we have reviewed about C++ and things that we already knew in C. Really? Let's check. Number one, a library. The library for saying so. Check, easy. Number two, namespace. We're missing that one, but I mentioned in the previous week, namespace, kind of your import for the packages. I put this to avoid writing std before saying so. So we can ignore that line. Just copy paste the line so you do not need to do extra code. The library, the namespace. Oh, an instruction here, define. We remember the constants in C. We still can use them here. So a definition, constant, size 4. So every time that I use size, that means 4. Is a constant that is going to be replaced in compilation time. It's not going to be a variable. Remember, const, define. Anyway, a constant. Then I have a class. My class, everything is public. Just to make things simple. Everything is public, and I have two variables. One is integer and the other is double. By the way, remember the enters and white spaces, the compiler ignore all of them. The only reason for you to use enters and tabs and things like that is to make your code easy to read, but the compiler don't care. So in this case, I just put two variables in one line, just to use the line and save space down, X and Y. Easy. Now, next, I have two methods. The methods. The name of the class is array object. Array object, and you can notice, the first letter is not uppercase. In Java, that could be a warning. Here, there is no rule about name of the classes being uppercase, lowercase. That kind of rules or notation is for Java. Here, any nomenclature is good. The name of the class is with lowercase. Well, the name of the constructor is with lowercase, and also the name of the destructor is with lowercase. Again, the only thing that I want to show you is whatever is the name of the class is the name of the constructor and the destructor. Doesn't matter uppercase or lowercase. You do not change anything. Now, the constructor. The constructor, the only thing that is going to do is to print a message. The same, the destructor. And I want to introduce a new friend. You can do cout, hi, a string, and print the \n, the enter. That is fine. Or you can print that. And L, enter, end of the line. Also you can do and then end L is a constant, and that constant is equivalent to the string \n. Look better then. Constructor and destructor, printing something. Yeah, the only thing that I want to do is print these lines. And as you notice, I have 4 calls to the constructor and I have 4 calls to the destructor, as should be. Now, the problem is that there are 4. Let's see what is happening. Main. The main is going to return an integer. Yeah, you can have a main returning an integer. That is fine. Next, inside of the main, array objects. That is the name of the class. Therefore, it's going to be the data type. I have two pointers. 2 pointers. In this line, any constructor is called. Question in your exam. First line in the main is calling a constructor, yes or no. Hopefully your answer is no. There is the name of the class. There are 2 variables. They are pointers, no objects. No constructor call yet. Okay. One of the pointers equal to new. New. Name of the class. Oh, that one is going to be new, and they are going to be objects from the class. Square brackets, just like in Java. New with the square brackets. What I am going to create is an array, which is going to be the type for all the elements in the array. Array object. It's going to be an array of objects. Yes, in the previous example, I showed you an array of integers. Now, an array of objects. The only thing that we change is the type, right? This is correct. Yeah, this one is a pointer. I can store here whatever new return is going to be the address of the first element of this array. The size of the array is size. Size is this constant here. I am creating an array of 4 objects. Each of those objects have a variable x, y, right? It's an object from the class. The class have x and y, the variables in the objects x and y. Help me here. An array of 4 objects. How many times do we call the constructor? Because there is only one new. That means one call to the constructor or more. If more, why? According with this output, the constructor was called 4 times. Where? Here? Yes. We haven't read yet the for loop. I mean, we are still above the line. The constructor is called 4 times because we create an array of 4 objects. The new in C++ automatically is going to create 4 objects. 4 objects in your array. And each of the objects is going to call its constructor. This object is going to print this, this object is going to print this, this object is going to print this, this object is going to print that. Exactly. The array is an array of objects. So each object calls the constructor. In Java, and this is the point in which the things become confusing. In Java, you need a new for your array. And then if that was an array of objects, you need a new for each object, right? Try to do this with Java. New for the array, and then a new for each of the objects. Well, the only reason because you do that is because in Java, you have an array, 2 objects, but really what you have is an array, 2 pointers, 2 objects. That is Java. Every single time that you create in Java an array or an object, always, what you have is pointers, always. When you create an array of objects in Java, you have a pointer to an array of pointers, and therefore you need the new for each of the objects. in the memory in Java, this is what you have. This is C++. Here, I am creating here an array, not an array of pointers. I am creating an array, a real array with 4 objects. And therefore, the constructors are being called 4 times, 4 objects. Good, whatever. I have my 4 objects, then I can do a loop here, and I can invite you to check the loop. The loop is something similar to what we did with C. Is basically I am using Q with an initial value P. They are pointers, so P is pointing to the first element, and I am doing this Q pointing also to the first element. So I have 2 pointers pointing to my array of objects, and then I am going to start checking a condition and incrementing a pointer. If you remember that the structures that we check with C, what I am going to do is this Q to point to the first element, and then I am going to do Q pointing to the second one, and Q pointing to the next one, and Q pointing to the next one. So I am moving this pointer through all the objects. And in doing so, I can use Q to access the variables that are public and put values there. And then I can do another for loop and use print things like the values, and print things like Q. And I want you to notice here that Q is a pointer, and I can print Q, and what I am going to have is addresses. Those are the values in Q. We do not need to use %P. That was in C. Here, the only thing that you do is you want to print Q, print Q. You want to print Q arrow Y or X. This is Y or X, and these are the pointers. You can print both the address and you can print the values. What I am printing here, just for you to know, is that each of these have similar values, but they have different addresses. Therefore, they are different places on the memory. Therefore, they are different objects. Anyway, constructor printing the address of the variables and the values. And then here, I use the new, and I use the new with the square brackets. I need to do the deletes. I need to remove the objects. I use delete. I need to use delete with the brackets also. Why? You create an array, you delete an array. You use the brackets here, you need to use the brackets here also. In this point, how many times or how many destructors are going to be called? That delete is going to delete the pointer for the array, or is going to delete the first element, or is going to delete all of them. Hopefully you agree with me. If with one new I create 4, my expectation is that with one delete, I delete 4. And if I delete 4, my expectation is that each of those objects have the opportunity to call its own destructor. Therefore, do something, each of them, before die. The last thing that every single object is going to be before dying is going to be call the destructor, its own destructor. And what we're going to have on the screen is object 1, 2, 3, 4, all of them calling the destructor. So 4 destructors exactly in this point with the delete. The method finish, that is the output of my program. Good. Hopefully it's clear. My recommendation, guys, please, homework. This program and the previous versions, copy, paste the code, run this in your computers, and be sure that you understand in which line exactly a constructor or a destructor is being called, how this thing is working. Moreover, the only new thing regarding malloc and free, they are now new and delete. Moreover, new for objects, new for arrays. delete for objects, delete for arrays. For arrays, the brackets. And that's it. Any question? Okay, guys, see you next lecture. Thank you.